years old. Hello, welcome to a review video on
Distance and ticket price.
yes, this
for
is Mr.
your
Lewis.
linear regression.
If you forgot, that's Lewis and Miller. I think we got that now.
Yes, and Mr. Miller is having a come to Jesus moment with his age.
Okay, yes. I'm sorry. I was just realizing, man, one of those guys looks really old in those videos.
I just said it wasn't me.
Yeah.
All right, so here we go. Here's our data with our distance and ticket price. So let's go through this. See if you guys got the right answers.
Yeah, they gave us the data. They gave us some summary statistics also down there. So we have multiple ways of doing this.
Right.
Okay, so define R squared. Well, you look in the same place where you find the line of best fit. It gives you A, B, R, and R squared. The value of R squared is 0.482. And so that's the decimal. Usually R squared is expressed as a percent. And so we might say equals 48.2%.
Mm-hmm.
All right, now also one thing you gotta be aware of is when they talk about R squared, usually they use a capital R.
Yes.
And then a little r for the correlation. You just got to remember little r, capital R stand for the same thing here. All right? So when it says explain what r squared means in this context, well, take a look. The response variable is fair, and we're using distance to explain the variation in fair.
Right.
So 48.2%
of the fair?
of the variation in fair.
Oh, of the variation. My
Yeah.
bad. I left out the key word.
Yeah, so 48.2% of the variation in airfare is explained by distance.
By the distance.
Okay, so if we add the line of best fit, there's still some variation around it. All right.
Mm-hmm.
Okay. So, but it's a measure of how good the line of best fit explains how much the fares are varying.
Correct.
All right, so find the slope of the regression line. We got the hard part out of the way. The slope is 0.079. And that was got by doing the linear regression.
All right.
The y-intercept, which is A, is 177.2.
177.2.
Okay. It says write the equation with a linear model. I know it's kind of hard for Mr. Lewis. Let's put fair. Oh, he's going to use y hat.
I'm going to use y hat just because it's hard for me to write. But
Okay.
you could have done fair hat.
Equals 177.2 plus 0.079 x.
Or distance.
Right.
Okay. Yeah,
So,
if you guys did words, it could have been fair hat equals 177.2 plus 0.079 times your distance.
okay. All right.
So-
Estimate the fare for a 200-mile flight. We just got to plug it in.
Yes.
All right. I'm sorry. I'm just flipping through. I have the quiz here, Mr. Lewis.
Oh.
So I'm just kind of flipping through it here and saying if it said define the variable. Oh, yeah. Just so you know, on the quiz, in one problem it does say define the variable. So if you use x and y, you would have to say where y equals the fare and x equals the distance.
Yes.
Or just use those words to begin with. All right, here we go. We're going to plug 200 in. We're going to try and keep this quick here. 177.2 plus 0.079 times 200. So using the line of best fit, our estimate in the fare for a 200-mile flight would be $193.
Okay.
You want to put a dollar sign? So this was.
I can.
There we go. Now 2,000 miles. All right. We can handle this. Put just another zero there. We would estimate that would cost $335.20.
20 cents.
Now, this is going to be hard for us to do. Maybe we can kind of, you can do it more accurately on paper. But 8 says, using these estimates, draw the line on the scatter plot. Add the line to the graph. So you could, maybe at least we can kind of roughly locate the points. When x is 200, y is 193.
Okay, so 200, 193, be somewhere around there.
Yeah, real hard to locate on the screen here.
Yeah.
And then 2,000 miles
Over here
is approximately
right? Yes.
335.
No, be right here.
Yeah.
330.
And then you could just draw the line through those points. And so this is pretty good here. Very hard on this thing to do that, but you kind of got the idea.
We'll just extend 2,000 up.
Okay. All right. So that's how we do it. Now, explain what the y-intercept means. All right, Mr. Lewis, how about the y-intercept?
Well, the y-intercept would mean that if you were not even to move from your terminal,
How much would it cost
that
you?
would be how much you would cost. We would pay $177 by just boarding the aircraft and not moving.
Yeah, so it says explain what the y-intercept means, so we're kind of doing it verbally. It's how much it would cost if you traveled nowhere. Now, does that make sense? That it would cost you $177.2 to fly nowhere.
Well, yeah, because generally there's a flat fee for something, and then they add on $1 per mile, and that's what your slope is. That's how much you're paying per mile you're going.
Yeah, but would you really pay to move to
No.
go nowhere? Yeah,
No, but that's the way.
Yeah,
like,
yeah,
everything
so that's
works.
why
It's
there
the
is a flat
operating cost of stuff.
but what I would point out is zero really part of the domain of the data.
No.
Yeah, so zero the y-intercept I would argue doesn't have a lot of meaning in this problem.
Yeah, but if you did want to explain it in context, that's how we would do it.
Yeah, the fixed rate and stuff.
Right,
Okay. All right. So explain what the slope means in this context. Slope always has a meaning. Going back to the y-intercept, Mr. Lewis, this one's kind of a little debatable, but you have to think: are any of the data values close to zero? Is one of the things to kind of think about.
Yeah.
This one's somewhat they're near 200, but that's why you have to consider with the y-intercept. Is it even near the graph of the data? Okay, for the slope, explain what the slope means in this context. Okay, well, the slope, maybe we could write the slope and we'll include units and then we'll explain.
Well, slope's right here.
Yeah. So
So
the
here, I'll
units
just-
would be,
So this would be the slope would be
The fares on
I'm sorry, dollars
per.
mile.
So I think it's helpful to find the units, and sometimes you might have to find the units, but it means it's about $0.079 per mile, which means 7.9 cents per
Mhm.
mile. So on average, for every additional mile, that's the x variable,
Yes.
the y variable, which is the dollars, increases by 0.079.
Right.
On average, every additional mile means you pay 7.9 cents more.
Exactly.
Okay, so remember the pattern. It's on average because it's the line of best fit. Every time the x variable goes up by 1, y variable changes by the slope.
Yes,
It's
it
kind of
does.
the pattern. Okay, how about 11?
All right. So fare to fly from LA to Atlanta is $212. Okay, but we got to figure out what did we predict. So 1719, we'd plug that into our formula so we can find our predicted value, which, Mr. Miller, you want to do that for us?
1719 seems kind of a pain, but okay. I'll do it. Just for you, Mr. Lewis, and these guys. 1719. Predicted value is $313.
Okay, so we have 300. We would predict it to be $313.
Mhm.
Okay, but the actual price was $212. So it's actual minus predicted is our residual, which is
Negative 101.
negative 101.
So it's a negative residual. The predicted was greater than the actual.
Yes.
Okay. In general, a positive residual, which is the opposite of what we have there, a positive residual would mean the actual value is bigger.
Yes.
So we could just say actual is bigger or predicted is lower. There's two ways of looking at this.
It's not going to want me to write now. Actual bigger.
Okay. And then in general, a negative residual means actual value is smaller or
Yes,
lower.
Lower. I'm just going to write lower just because it's going to take me forever.
Okay. I like this problem because it hit a bunch of key concepts.
Yes.
And
Yes, it did.
we had the data and we had the summary statistics. We could have went either way with this.
Mhm.
We could have just used those summary statistics on the bottom to find all of this.
We could have.
But we entered the data and used it. All right. Check out the other two review videos.
All right.